Hi, I'm Aaron Mullen. I'm a software developer and data scientist here at the Center for Applied AI. And today I'm going to talk about a self-service tool that we've developed here called Classify. Classify is a web-based tool to be able to perform machine learning classification very easily without needing a lot of coding expertise or programming background. It allows you to upload any kind of tabular data set that you have, like a CSV file, and choose which columns you want to include in your data set. When you upload it, you can choose all of the models that you want to use, such as a random forest model or a neural network. And by choosing some simple parameters, you can send the job off to begin training without having to code anything yourself. And once it's done, it will give you the results for your data and show different performance metrics, visualizations, and some other cool features that I'll show you here today. So the Classify interface looks like this. This is on our site data.ai. And here we can add new data files as well as view any of the older data files that we've uploaded before. So if I upload a new data file here, I can choose any CSV file that we have. And this CSV file can include many different kinds of columns. It can have numerical data, binary, even categorical string data. The only requirement is that we have a classification column, and that's whatever we're interested in predicting with our machine learning models. So in a medical context, that might be a diagnosis of positive versus negative that we're interested in predicting using these other features. Once we have our data set uploaded, we can hit preview, and we'll see a list of every column that we have in our data. We can scroll through all of these here. So in this example, this is a breast cancer data set that classifies patients based on malignant versus benign and has different kinds of measurements here. So on this screen, what we can do is choose whether or not we want to include any of these columns, if we want to get rid of them, and we can change the types of these columns as well. So for example, if we have an index column, we might not want that as part of the data, but most of these other ones we'll want to keep for testing. These are all a lot of measurements, so they're all different float variables, but we can have different kinds of variables as well. If we had any missing data here, we could also easily fill in the missing data here. We can choose a couple different options for how we would want to fill it in. That can be choosing a constant fill value that we just want to fill any missing variables with. We can also synthetically fill them or just drop those rows altogether. Once we've chosen all of the columns that we want to use, we can upload our data set here, and it will be stored on the site here. You can see that when we go back to our results page, we have data from previous runs, and we have our new data set that we've just uploaded to. Here we can then choose to prepare our data set, and we can get ready to begin the job that we want to train. So there's a lot of different options on this page, but a lot of them aren't necessary to change. A lot of them, their defaults will work fine in most cases. But some of the important options that I want to point out here, you can choose whether or not your data set is multi-class or not. So that means that you have more than 2 unique classes in your data set that you're interested in predicting. We also have what are called SHAP scores, and I'll show what those look like once we start our job, but they are ways to provide feature explainability to your data set. So one of the problems with machine learning models a lot of the time is when you upload a data set and run your data through the model, you get results, but you don't know what those results actually mean or how you got them. And one of the advantages of using Classify is that we provide explainability to the models. It actually shows you which of your features are the most important for your data, so you can learn more about the data itself and how it relates to the classification you're interested in. We can also choose to parameter tune the models. That means that we would run through many different combinations of different parameters for each model to figure out which ones work the best for our data. On this side over here, we can also choose to generate synthetic data. So this can be very helpful in a number of cases. Sometimes our data set is very imbalanced, meaning we have a lot of different we have a lot more of one class than the other. And if that's the case, a lot of times machine learning models won't work very well because they will focus too much on the majority class. So by synthesizing more examples of our minority class, we can help the machine learning model treat both of those classes more fairly. We can also generate entirely new data sets. Maybe we have protected health data that we don't want to actually use. We want to use synthetic data based off of that. So we can actually generate new synthetic rows that use kind of the same trends and relationships as the original data, but without any of the same actual data as before. At this dropdown, we can choose all of the models that we want to train. So you can see there's a lot of different models here, 10 total, and a lot of them use different kinds of architectures to produce their predictions and work in different ways. If you don't know what any of them mean, though, you can just train all of them and see which ones work the best. You don't necessarily have to understand how they work on the back end to be able to use them. We have some other general parameters here that we can change as well as a lot of other specific model parameters. So these were provided because we wanted to give as much customizability as possible for people who understood how these models worked and what these parameters mean. Then we want to provide the ability to go in and change those as you need to through the web interface. But you can always just leave them at their defaults as well. And most of the time that will work for most data sets. Once we've chosen all of our options that we like, we can submit our job for training. What will happen then is that a notification will be sent to our DGX cluster, which is our high performance computing system here at CAAI. And the DGX cluster will actually run the job for us. So it will send all of the arguments that you've chosen on this page over to the DGX, and it will pull those down and get the data set and actually run all the models right there on that system, so you don't have to run them. After it runs, it will produce results and visualizations and everything for all of your data, and then upload those back onto the site so that you can view it here. So if we go to our results page, we can then go back and look at one of these results to see what it looks like. And you can see on this page, besides just viewing the results, we can also rerun our data. So this makes it very easy to check other parameter options and other settings to see how it affects our performance. When we view our results, what we'll see initially is a big table with a lot of different performance metrics. We have all of the models that we've trained over here in this column, and we have different metrics such as the area under the ROC curve, accuracy, sensitivity, and specificity. Now we can compare these directly in the table and we can sort them as necessary, but we'll actually have other visualizations that will make it a bit easier to look at these metrics. Up here at the top, we have a couple different options for more things we can do with our results. We can choose any of the results choose any of the models that we have trained here and download any of them for further use. So if you want to take the models and use them in the future in some other context, you can easily do that. But if you're just interested in retesting your models, you can actually do that right in the web interface as well. By selecting any models and clicking retest, it gives us the option to upload a new file that we want to test with. Now, if that new file has a class column already, then it will simply produce accuracy and sensitivity and specificity and all of the other metrics. But if the data set that we upload doesn't already have a class column, it will produce its classification predictions for every row of your data. So you can just directly use the model through the web interface and get new predictions for any new data that you acquire. You can also download any of the data, including any synthetic versions, and export the results table to a CSV file. Finally, we can view the visualizations here, and this allows us to compare the models in a more visual way. So here we can see a heat map with our different models on the bottom and different performance metrics along the side. And by comparing this heat map, we can see which models perform the best in a variety of different performance metrics. So here we can see that this model has the highest values in every case, but we can use this to compare and see which models work better or worse. We can also compare things like the true positive and false positive rates with a graph like this that shows us what percentage of positive cases were classified correctly, as well as what percentage of negative cases. We can compare results on different versions of the training or test sets as well to see how well our model generalizes to data that it has not seen before. And we can also choose a variety of different SHAP diagrams to look at. So this is the feature explainability that I mentioned earlier. This allows us to see which of our features have the biggest impact on the model and how they're impacting it. So in this example, we can see that we have a list of features of our data here on the left-hand side, and they are ranked in order of their importance to the model. And the graph here helps show what their impact was. So it can be a little difficult to interpret at first, but the colors represent the values of the features. So we have red representing higher values of that feature and blue representing lower values. The position on the x-axis here shows the impact on the model's performance. So you can see in this first feature here, we have a lot more red on the right-hand side and a lot more blue on the left-hand side. So we can interpret that as meaning that higher values of this feature are more associated with a positive classification, whereas lower values are more associated with a negative classification. So we can do this for all of our features to see how they are impacting the model, and we can compare between different models as well and see what they have in common and what they disagree about. And by looking at all of these diagrams, we can get a better idea of what our data actually is and how the different columns relate to each other and how they can impact the classification that we're interested in. So with all of these tools, we're able to understand a lot more about how our machine learning models work, and we can easily train them without needing to actually write down the code to build and evaluate those models. We can view all sorts of different results and visualizations. We can generate any synthetic data that we want to use more in the future, and we can continue to test the models that we've trained and tweak them by retesting with the same data. So by using this, we've provided a lot of help to various departments that have data like this and need to identify these kinds of classifications automatically. So if this seems interesting to you, make sure to reach out to us and we can work with you to get access and show you more about how to use this tool.